Shalom to you. So in this video, we're going to continue to review 4 circles for the test. Okay, so other parts of the circle is very important to identify different parts of the circle. When it's the diameter, the radius, the circumference, the minor sector, the major sector, the arc, major arc and minor arc, and segment and tangent. Tangent is always perpendicular to the radius and the diameter. Likewise, diameter, perpendicular bisector theorem is perpendicular bisector. Okay, hold on, this is not working. I don't know why it's not moving. Okay, so the perpendicular bisector theorem that a radius, I don't know why people seem to forget that, a radius perpendicular to a chord bisects the chord. So whenever a line runs through the center of the circle, whether it is a complete radius or part of it, as long as it passes through the center, it bisects the chord. Bisects the chord, and so if two parts of a chord are congruent, the midpoint must have a line pass through the center. Okay, that you need to remember. So let's solve one of the problems. Again, this is the way the problem will be in the test. So you get a feel of it. So you may be given just a statement. You'll be able to draw your picture and then solve the problem. So given a circle with that. So draw the circle. They told us that the radius is 13. And we asked, there's a length of the chord. Chord has to run from one side of the circle to the other circle. So you can draw your chord anywhere you want. And then, so again, but then you need to think of mind how it can help you solve the problem. We asked how far the chord is from the center. So I'm going to draw that in a different picture. So this is the center of a circle, and that is drawn to this chord. And the perpendicular bisector theorem says that once any segment is drawn from the center to a chord, it must be perpendicular to it. So it's perpendicular there. And then we can draw as many radii as possible. So since this radius is not connected to our chord, we can draw another radius to connect to the chord. That radius will still be 13. We can even draw here also if we want, but gives us, a right triangle to work with. And so since this line is perpendicular to the chord, it means it bisects the chord. So these two segments will be congruent. That makes this side to be 12 and this side to be 12 also. And then we are looking for how far, the distance. So we can label it D. So it's not a full radius, because radius goes all the way to a point on the circle, but this is not a full radius, but going to be part of it. So now we can use Pythagorean Theorem. So be careful to know what your two legs are. Okay, hypotenuse is always opposite the right angle. So the hypotenuse is 13. 13 squared is equal to 12 squared plus D squared. Okay, and then we can simplify that. 13 squared is 169 equals 144 plus D squared. Subtract 144 from both sides. What's that? 25. Good thing is a perfect square, so we can just take the square root of that and we get our D, which is 5. And since we labeled D is the distance we are looking for, that will be our answer. Okay? Any question? So sometimes you may be given the radius and the distance and you're asked to find the length of the chord. Be careful when you do that, because you will only find 1/2 of the chord, which is part of the right triangle. So you have to double it to get the whole chord. All right? So, but that's the same way you solve the problem. So let's look at length of arc. Again, arc length is going to be, since it's the distance around, it's going to be part of a circumference. So you find the circumference, which 2 pi r, and then multiply it by the fraction of the angle. Because if this angle is 210, this arc is going to be 210 also, the measure. So we have to take that, the part of the arc over the whole arc, which is 360 degrees. Okay, that fractional part, okay, 210 divided by 360 is going to be 7 over 12. Okay, and then we put the radius is 15 times pi. So if we are not asked to round, then we have to keep the whole answer. So we multiply 2 times 15 is 30. 30 times 7 is 210. So we have 210 pi over 12. So we can reduce it. It doesn't seem like it goes evenly, but we can write it in simplest form and then keep it like that. So that will be reduced to 35 pi over 12. So we just simplified 210. So that's the arc length. Okay, we leave our answer like that if we are not asked to round. Right? So these are straightforward. And then the sector. Area, area is two-dimensional. Two-dimensional. So the area of sector is going to be a part of area of a circle. So find the area of a circle, which is pi r squared, and then multiply by the fractional part of the angle again. So that's still going to be, that's 7 over 12. And that's pi. The radius is 9 squared, which is 81 times 7 over 12. Okay, don't forget the pi. So now multiply the number 81 times 7. So we get 567 pi over 12. See if we can simplify it, write it in simplest form. Yeah, it is simplified to 189 over 4. This is, make sure pi is on top, and that will be the area. All right? Okay, come on. All right, so we move on to tangents. So you need to be able to tell when it is interior tangent, when it crosses the, if you draw a line to connect the segments like that, and it crosses it, that's when you know it is internal. And if the line doesn't cross it, then you know it is external. So like these would be internal. Okay, these would be external, because if I connect the two centers of the circle, it doesn't cross it. So that would be external tangent, internal tangent. Okay, a lot like that. When they have one common tangent here, so when you have concentric circles, which is concentric, they share the same center. They are not tangent at all. It's not possible to have a tangent between those two circles. It's not. Likewise, when they are not concentric, but one is inside the other, they are not touching. They have to be touching somehow to be able to have a common tangent. Make sense? So identify those. So this is number 8 problems on your from that. Okay, that's the very famous one. So if we label what is given, first of all, label each of those sides. So we're given that AB is 7 and BC is 10 and CA is 11. Okay, so that's the whole length, but we need to remember that all radii are congruent. All radii are congruent. So this is a radius of circle A. The radius goes here. This is also a radius of circle A. So let's label it small a because it's a length. They're going to be the same AA. Whatever we don't know, just represent them with variables. Okay? And then you will come up with an expression and then write an equation too. So you won't always have a number. If you don't have number, put a letter there to represent the number. Okay? And if you find a way to. So likewise, this will be B and this will be B because they are going to be congruent. They are radii. And this will be C and this will be C. Again, I'm just using small letters for those to help me remember the circle that has them, the radii. Otherwise, you could use any variable. Okay? So now we can create equation, system of equation. We know by segment addition postulate, a plus b here would give us 7, right? So you write that down, a plus b equals 7. Which implies if we subtract b from both sides, so a is going to equal what? 7 minus b. Does that make sense? Okay. And then we write the other equation. We know that a plus c is what? A plus c is 11. Okay. So, and we also know, I'll write that here, that b plus c is 10. So these are all true statements, right? And then since each one of them have, at least a couple of them have the same variable, we can use substitution. We can go ahead and take like this one, we can substitute, we have a here equals to b, this one has b, this one has c, a plus c. We can also solve for one of the variable here if we like. We can, since we solve for a here, we can go ahead and solve for a here also, right? What do you think? Or we can solve for c here and then substitute in the other one.